create a column of the partial sums. So I'm going to select the table, and then I'm going to go to Table and add, no, where's calculated column? Why isn't that showing up? Add formula, formula. Okay, so we want a formula, and that's going to be for the kth partial sum. But before I can do that, I need to define what the kth partial sum is. So I'm going to need a new function, and we'll call it capital S for partial sum. Okay, and that's going to be the kth partial sum. And so how do I express the kth partial sum? How do I do that? So I'm going to do summation, so Control Shift S. Okay? Now we got to think about this. When we say the kth partial sum, what we're saying, we're adding up the first k terms, right? So what should this be? That should be k. So we can't use k for the index in the summation. K is what we're summing up to. It's like it's the number of the last one. So that means we need to do what? We need to choose something else. I'll choose j, okay? So j, and then j is going to start at 1. And what do we want to sum up then? We want to sum up when j equals 1, then j equals 2, then j equals 3, and j equals all the way up to j equals k. What are we going to sum up? So what should it be? S of j, right? It has to. We have to cycle through every value up to k, and then we get the kth partial sum. So do you see how I'm using the j there? Okay, so now I've got this. Now I've got this function s of k, and then they said check s, the 11th partial sum. Is that right? 11th? What was it? 11th, and it should be 132. So it's right. So now in the table, watch, this new formula, I can do capital S of k, and it finds me all the partial sums. Look, there's number 11, 132. But it'll just give me all the partial sums all along the way. It worked in class, finally. Every time I try to do this in class, it doesn't work. All right, so I think that was part of your homework, and I knew I didn't show you that. You're not going to be graded on that, but I did want you to look at it and think about it, and then I wanted to show you because for next week's homework, you'll have more of these. Okay? Any questions on that? Okay, the exam. I just want to go over a few items on the exam. I crunched all the numbers. I put the results on Blackboard announcements. You can see your score out of 100. I think it's called just exam 2 score. And then you can see your free response and multiple choice raw scores also in Blackboard. Okay? Chance to talk through these questions, which will help. So talk to the people around you. Take 5 minutes. Okay, we're going to go over it. Like I said, if you got up to E, that would be considered full credit. So I want you to look at what you wrote as I go over it, but you can't change what you wrote. So if you would put your pencils away, please. And you guys would watch that for that, please. Okay, so what's the general idea here to get an approximation of a change in height? dH equals what, like m dt, which is the same thing as generically dy equals m dx, right? So this is our change in dependent is the rate times the change in independent. So that was the cue in the warm-up, or the questions I answered. So if we're doing a left-hand approach, we're going to do the rate. So this will be the rate times the change in time. The change in time is 0.15 every time. So it'll be the first in the sequence will be negative 0.75 times 0.15. And then next one in the sequence, negative 0.75 times 0.15. Third interval, negative 0.5 times 0.15, etc. So dy equals m dx. In this case, dh equals m dt. These are our changes in height. Did I make a mistake? Probably. It's hard to talk and write at the same time. This one here? Do I have it right now? Questions on that? So it's a sequence of approximate changes. Each approximate change is calculated by rate times change in time. Please. But it's rate times change in time. Rate times change in time, the duration of time.
Yeah, so wouldn't be the first term 0 times?
No, because that's saying that your change in time is 0. The change in time, so each interval has a change in time of 0.15.
Yes, but
0 isn't a change in time. That's a particular time, moment in time. To get a change in height, we need a rate times a change in time. So every change in time here is 0.15. It's kind of like delta t. When we did, this is more like delta t than it is dt. So it's more like m delta t. Okay, so the series then would be what? Whatever you wrote in the sequence, you're just going to take those and add them up. And do we have consensus on what that is? Negative something? Negative 0.36? It's different than last semester. Did everyone get negative 0.36? Lots of people? Yeah, you got that? What's that?
I got negative 0.4725.
Yeah, that sounds more right. Did I get all of them here? 1, 2, 3, 4, 5. Yeah, so it should be, that sounds more right. Just from my recollection. 0.4725? That's what you get when you add those up. Okay? First three terms in the sequence of partial sums. What's the first term? Negative 0.75 times 0.15. So what's the next partial sum? It'd be these two added together. It'd be the first term plus the second term. That's the second partial sum. That would go there. And then the third partial sum would be the sum of those, the sum of the first three added up. It'd be added, right? So added. I'm not going to take the time to write that out. Does that make sense? Any questions on that? Okay, so the meaning of the series when you add all these things together. So what is the meaning of that number? What did it has meaning in the flag context. What does it mean? Yeah.
It's the accumulated change in height.
Accumulated change in height for the first
5 intervals.
Yep, so that would actually be 1, 2, 3, 4.
First 0.6.
Yeah, so it's the approximate change in height accumulated for the first 0.6 seconds. Because we're taking the first little change plus the next little change plus the next little change. So adding up all those changes, we get the accumulated change in height of the flag, approximate, in the first 0.6 seconds. Does it make sense? Questions on that? Please take your pencils out of your hands. Okay, that's the meaning of the value. Okay, so then the sequence of partial sums, saying that, and then that plus that, and then that plus that plus that, is a representation of something really important we've been working on all semester. Who thinks they recognize that, what that is? So the first would be that change, and then the sum of the first two changes, then the sum of the first three changes. I'm looking at D2. What does that represent? Yeah. Accumulation. What about accumulation? Okay, but the fact that it's a sequence. So yes, there are accumulations. The fact that it's in a sequence means what? What is it? What's that? Okay. But it's a sequence. It's more than one value, right? So when you say accumulation, that just means one value. Like I'm getting 3 values or a sequence of values. What's that like? Function, right? Net accumulation function, right? So if 0.15 seconds goes by, I've got that much change. If 0.3 seconds goes by, I approximate that much change. 0.45 seconds goes by, or sorry, 0.15 would be this one. Then 0.3 seconds goes by, it approximates this much change. That's the idea. That sequence is the idea of the net accumulation function, right? Gives us all values of net accumulation. In this case, just 3. Okay, but it's like I said, representation. Okay, now this one. So the first interval goes from 0 to 0.1. And so how would we write the approximating rate for that? So here's where your thing comes in. So what is that approximating rate for that interval? RH of 0. Function notation, right? RH of 0 would be the first approximating rate for the first interval. So we'd have R sub h of 0. Okay? What's the next approximation? So the second interval goes from 0.1 to 0.2. We're going to use the left-hand side to get the rate. So the rate is R sub h of 0.1. So that's the approximating rate in the second interval, and then etc. Approximating rate in the third interval. What's the last one? So we're going to go all the way to, if there's 60 intervals, it'll be R sub h of 5.9. That's the last one. Because it's the left side of the last interval of a 10th width, right? The widths are a 10th. And the left-hand side of that is going to be RH of 5.9. Bonus if you got that. Questions on that? Sequence of partial sums. Okay, sequence of approximate changes. So how do I get, I've got the, sequence of constant rates. So I've got the constant rates now. How do I get the changes? Rate times change in independent, which is 0.1. Next approximate change. Times, this is basically the same as at the top of the page, but we're using function notation to express the rates now. Point, etc. The last one will be R of h 5.9 times 0.1. Okay, so now we need a formula for that. So we're looking at this. Say this is the, what is this? This is I equals what? 3. This is I equals 3. So what is the formula for the approximated change for the ith interval? How do we get that? It's going to be R sub h of what? Over? Yeah, so to get from 3 to 0.2 and 4 to 0.3 and 5 to 0.4, first we have to yeah, you could start doing that. Yeah. So you could take I, right? You take I, what? Minus 1, and then do what? Divide by 10. Times 0.1. Anybody get that? Did anyone get that? Just one? Anyone get something close to that? Do you follow it? You follow where we got the approximate rates from, and then those input values are always like 1 behind, but a tenth of 1 behind what the index is. So you got to subtract 1, divide by 10.
I have a question.
Yeah.
Would it be correct if I did it at 0.1 times RH of I minus 1? Would that be correct?
But I minus 1 is 2, not 0.2. Right? So like this case, you still have to have that little divide by 10 inside. But no, you're really close. That's really good. So the only thing you were missing was the divide by 10? Yeah, that's good.
Wait, how did you know it was divide by 10 again?
Because 3 gives me an input value of 0.2. I equals 3.
3 minus 1 is 2.
Yeah, 3 minus 1 is 2, but then you need to divide by 10 to get 0.2. Yep. Okay, so what's the series? In 2 ways. It would be adding these up one by one, and then this summation notation of R sub h, I minus 1 over 10 times 0.1, and then I equals 1 to 60. Finite sum. Finite series. Other question? Yeah. Oh, the meaning. So the meaning would be the net accumulation of changes in height for the first 6 seconds. Is that what you thought?